All right, so we have some more marking period exam review. I apologize, I do have a cold. Okay, diagram below represents a portion of a 100 milliliter grad cylinder. What is the reading of the meniscus? So here's 30, here's 40. Looks like each of those go up by 1 whole milliliter. We're right there in the middle. It's 31, 2, 3, 4, 5. And so we're sure of the tens, we're sure of the ones. We are estimating the tenths, so 35.0. Which set of laboratory equipment would most likely be used for the crucible? So crucible is really small. I'm going to go with A, which is crucible tongs and a clay triangle. These are test tube tongs. These are crucible tongs in D, but this is an Erlenmeyer flask. Which Kelvin temperature is equal to 200 degrees Celsius? So I go to reference table T, and I see that the formula Kelvin equals degrees Celsius plus 273. So 200 plus 273 is 473 Kelvin. All right. The diagram below, grad cylinder. So I guess the question is how many decimal places. So we are sure this is 70, sure this is 80, this is 71, 72. So we're sure of the tens, we're sure of the ones. We are not sure of one beyond, which is the tenths. So we cannot have 2 decimal places. So 70, 1, 2, 3, 4, 5, 6. So it's 75 and some change, 75.7. Triple beam balance, okay, so I'm sure of 545, so that takes care of those. So then this is 5.1, 2, 3, 4, 5, 6, 7, yeah, so each of these are worth 0.1, so now I'm going to erase that so we can see a little bit better. So it looks like it's right on 0.2, and then we have to estimate one beyond, so 0.20. Diagram below represents a metal bar, 2 centimeter rulers. What is the greatest degree of precision for each? So on ruler A, we are sure of the ones, so the best we can do would be the tenths. Over here, we're sure of, it looks like these are the tenths, so we're going to go to the hundredths on here, because you can always estimate one beyond what's written. So ruler A is, here we go, choice C. An increase in average kinetic energy means an increase in temperature. So first of all, we need to make sure, apples to apples, we have everything in the same temperature scale. So this is 288. 288 to 298 is an increase, so that's probably our answer, but let's just make sure. This is 310 to 273, that's a decrease. 273, so that would be a decrease. And then 25 plus 273 is 298, which is also a decrease. So average kinetic energy is temperature. An aluminum sample has a mass of 80.01 grams, density of 2.70 grams per cubic centimeter, according to the data to what sig figs. Okay, so we're going to do density, so volume, excuse me. So density is 2.70 over 1, mass is 80.01 over V. So when we do this math, we're going to eventually, we're multiplying and dividing. So we're going to need the fewest number of sig figs, so 4 divided by 3, which will be, or 4 and 3, which will be 3, the fewest number. Thermal energy, table D, and that will be joules. 200 joules, so we're talking kilojoules, so 200. The conversion factor is there are 1,000 joules in 1 kilojoule. On table C, it tells you kilo is 1,000 times larger. So 200, divided by 1,000 is 0.2. And then here it is. They just add some extra zeros because of the sig figs, which has 4 sig figs. So anything less than 1 with a decimal, obviously that's just 2. This is 3, all of those are 4, and this is just 3. So there's that. When you add, this is the fewest number of decimal places. So 2 decimal places, 3, Decimal places, so you have to have an answer with 2 decimal places. That's not it. We're looking for somebody who has 1 decimal place, which is C, right? 1 decimal place, 1 decimal place. Yeah, that's it. Oh, by the way, notice how I'm getting a whole bunch of C's in a row? I don't care. I don't create the answer key as, the location, so don't get that in your head. All right, so 10 joules, 1,000 joules are in 1 kilojoule, which means divide 10 divided by 1,000, 0.01 kilojoules, choice B. Okay, so we got to round this to 3 sig figs. So 1, 2, 3. Does a 0 round that up? No, so 0.410. Percent error. This formula is on table T. Okay, so a student intended to make a cell solution with 10 grams of solute. The student's was analyzed. It's found to contain 8.90. So percent error is basically subtract any way you want. You have to divide it by your accepted times 100. So our accepted is, I guess we're going with the 10. 10 is the accepted. And we found 8.9. So I'm not going to subtract in such a way that you would have anything negative, because anything negative we're just going to make positive anyway. So 1.1 divided by 10 is 0.11 times 100 is 11%. Percent error again. Accepted value is 22.4. We got 24.8. 24.8 minus 22.4 over 22.4 times 100. So now let me do that. It's 2.4 divided by 22.4 times 100. 10.7. The temperature of a sample changes from 10 degrees Celsius to 20 degrees Celsius. So T final minus T initial is 10. How many Kelvin does it change? Well, if I made 10 degrees Celsius, that would be 283, and then this would be 293. T final minus T initial is also 10. This does not mean take 10 and make it Kelvin. This is just what is the change. The change is the same. What is not lab safe? Leaving things unattended. Why should you not drink from glassware? Chemicals are poisonous, yes. Which is not lab safe. Again, wearing goggles is safe, wafting is safe, chemicals down the drain. All right, Q equals MC delta T. However, now that I'm looking for a final temperature, I'm going to adjust that slightly and say T final minus T initial. So 209 equals 10. This is water, so it's 4.18. T final is what you're looking for, and T initial is 23. And sorry if you can't read that. So 10 times 4.18 is 41.8. So I'm going to read this here. 209 equals 41.8 times T final minus 23.0. So divide both sides by 41.8. 209 divided by 41.8 is 5 equals T final minus 23.0. Add 23 to both sides. So 5 plus 23 is 28. That's as hard as it's going to get. 3 forms of energy. Exothermic is not a form. Endothermic is not a form. Electromagnetic are 2 different forms smushed into one, so you're going to go with 3. Oh, no, sorry, whoops. Temperature is not. Oops. Electromagnetic would work, even though it is smushed together. Release of energy means exo. So when a solid becomes a liquid, we are absorbing heat, melting. When a solid becomes a gas, we're absorbing heat. When a liquid becomes a gas, you have to absorb heat. When a gas becomes a liquid, we give it off. D. All the exos are like this. In a laboratory where the air temperature is 22 degrees Celsius, a steel cylinder at 100 degrees is submerged. All right, so heat's going to flow from hot to cold. So the hottest is the steel cylinder. So heat's going to flow from the cylinder. No, you're not flowing to the cylinder. Cylinder's the hottest. The air is also going to flow to the water. Nope, the air is colder. The air to the water. No. The cylinder to the water. Yep, and the water to the air. That's right. Hot to cold. Oh, let me erase this now so we can read it. 50-gram block of copper at 10 is carefully lowered. Okay, how is heat going to flow? So hot to cold. The water loses heat to the block until both are 10. The water is at 90. Water's going to lose heat to the block. The water will lose heat, but it's not necessarily going to be to 10. Block gains heat from the water until they're both at 90. No. The water loses heat and yes, it's C. The water loses heat and the block gains heat to some temperature between them. All right. Let me just make sure the water is at 90. Yeah, so it's losing. Okay. The temperature is the average kinetic energy. So, C. Average kinetic energy is the highest temperature, so we don't care about volume. So here we go, A. Exothermic, gas to liquid to solid. Or gas straight to, holy cow, that is not right. Gas to liquid to solid, or gas straight to solid. Solid to liquid is not, solid to gas is not, liquid to solid, yes. Another one of these, Q equals MC delta T, we're looking for mass. 420 equals mass times, now specific heat of water is on the front of the reference table, T final minus T initial is 10. So 4.18 times 10, 41.8 times M equals 420. So 420 divided by 41.8 gives me 10. Giving off heat, so Q 50, it's again water, so 4.18. Delta T is 10. So 50 times 4.18 times 10 is 2090. Well, that's not here, but something really close is. 2 grams of potassium chloride are completely dissolved in a sample of water in a beaker. So dissolved in water. So we're making a mixture, first of all. So if you're dissolving and completely, it's going to be homogeneous, the same throughout. A mixture would have to be something aqueous, okay? That's lithium chloride and water. All right. A mixture of elements A and B. So in X, we have A bonded to B. That is a compound. In Y, you have A diatomic element. Why did I just stop writing that? Z, we have a mixture of element A and element B. So it is just Z. How could you separate sand and water at room temperature? Ionization, filtration, combustion, or sublimation. So we're going to filter it. We're going to pour the mixture through. The water will pass through. The sand will stay. Sand is large sizes. Which can be separated by physical means? Any mixture. A beaker contains alcohol and water. Why can you separate them? Because they have different boiling points, and that's distillation. 37. Carbon is classed as an element rather than a compound because it has been known for many centuries. No. Combines with oxygen to form a gas. So. Cannot be chemically decomposed. Yes, that's true. Is formed? No. So. Elements. Detergent, wood, barium, brass, hydrochloric. Okay, first of all, if you didn't know, Table S has a whole list, or you can look on the periodic table. Barium is an element. Detergent is a mixture. Wood is a mixture, I guess. Definitely not an element. What is a mixture? Baking soda, sugar, air, salt, or water. Definitely not water, salt, sugar. Baking soda is also a chemical. Air is a mixture of gases. A mixture consists of two or more components in any proportion, equal proportion, definite proportion, constant proportion, one proportion only. Well, salt water from the ocean is super salty. Salt water, called saline for your contact lenses, is really not salty. So any proportion I'm going with. Which has the least mass. So remember, it's always mass over atomic number, or number of protons. So the number in the top left. So 4, 1, 1, or 0. Least mass would be 0. Okay, historical development of the atom. So atoms is small, dense nucleus. No, nucleus is not the start. Hard, indivisible spheres, yes. So it's definitely D. Then small negatively charged particles. Yep, it's got to be B. They both are. So the difference is does C come first or A come first? C, the center is a small, yeah. The nucleus comes first and then electrons. So C, then A. So this is choice D. Which should be used to accurately measure 185 milliliters of an aqueous solution. So we want a graduated cylinder. What subatomic particles are found in the nucleus? So in the nucleus we have protons and neutrons, which means overall the nucleus is positive, which means the negatives out here are going to cancel out charge, but they are out. So neutrons and protons. Charge of an electron and the charge of a proton. So electrons are negative, so they're not both. And protons are positive, choice D. What's the total number of electrons in a potassium atom? So potassium, if I go to periodic table, potassium is number 19. So 19 protons, which means we'd need 19 negative electrons to cancel it out. What is the overall charge of an ion that has 12 protons, 10 electrons, and 14 neutrons? I'm going to get rid of this right away because it has no charge. So 12 positives and 10 negatives. It gives me overall plus 2. Excuse me. In the late 1800s, cathode ray tube, that was J.J. Thomson and the electron. Mass of the proton, which is 1 AMU, is approximately equal to the mass of. Okay, so this is table O. So if you go to table O, which I'm doing right now, you're going to see that an alpha particle has a mass of 4 AMU, so that's not the same. A beta particle has a mass of 0 AMU. A positron has a mass of 0 AMU. A neutron has a mass of 1 AMU. All right, what is atomic number and mass number? Okay, so first of all, atomic number is the number of protons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Atomic number is 9. Mass number is add everything. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Mass number is 20. As a result of gold foil, it was concluded that an atom contains now small dense nucleus. Yes. What is the charge of the nucleus of an oxygen atom? So oxygen has 8 protons and it has 8 neutrons. However, the only ones with charge are protons, so it's going to be plus 8. Gold foil experiment led to the conclusion each atom was composed of mostly empty space because the alpha particles directed through, they went right through. Because if they go right through, there's nothing to stop it, so it shows it's empty. Another one about historical, hard sphere is definitely first, empty space, then electrons. Sphere, electrons, empty. No, empty space comes before electrons. So what does this tell us? It tells us the mass number, but it also gives us atomic number. So this is the mass number. That's atomic number. Why is an atom neutral? Because protons, which are positive, equals the number of electrons, which are negative. What is the total number of valence electrons in germanium in the ground state? So germanium, you don't know. GE, right? Germanium is GE, it's number 32. So then I go to periodic table. Germanium says 2, 8, 18, 4. So germanium has 4 valence electrons. 4 are the outermost. The average mass of magnesium is the weighted average of all the artificially? No. All the naturally? Yes. Holy cow, that's a B. What is going on here? So number 59, if you've got 8 protons, atomic number would be 8. Atomic number of 16, nope. Mass number of 17, 8 plus 9, yes, that's true. Isotopes have the same mass number and atomic number? No, different mass numbers, same atomic number. So again, isotopes, no. Oh, sorry. Different mass, same number of protons. Actually, that is the answer. You've got different elements here, you've got different elements here, you got different elements here. All right. Hydrogen has 3 isotopes, mass numbers 1, 2, and 3, but the average atomic mass is 1.00. See how it's skewed way closer to 1? That means there's way more isotopes with atomic mass of 1 than the other two. So when you do an average, it's weighted that way. All right, now we're doing average atomic mass. 75%, so you can do it 2 ways. One way is you can keep them as percentages, 75 and 35, multiply. And then we've got 25 and 37. Then you divide by 100. The other way to do it is if you make those percentages into decimals, 0.75 times 35 and 0.25 times 37. So I like that second way better. 0.75 times 35, 26.25. 0.25 times 37, 9.25. Add them together, you get 35.5. Energy of the shells. Okay, so if you're at a concert in your front row, low energy because you're just watching everything, you're seeing it, you're hearing it. You're in the last row of the concert hall, you can't see it very well, you can't hear it very well, so you're putting a lot of energy to see it. So first shell has less energy. Third has more than the second. I read that real fast, hold on. First shell has more than the second now. First shell has the same as the second. Third has more energy than the second, yes. Third has less, okay, good. In a calcium atom, the ground state, the least amount of energy are the first, closest to the nucleus. When ground electrons move when excited go to ground, the electrons are giving off energy as it moves to a lower energy state. Super important, we know that. The excited state will not follow Bohr, so 2, 8, 18, etc. So 2, 7 is on the way to following that. 2, 6, 2, this is not following it because instead of filling to 8, we went on. So I think that's my answer. This is filling correctly, and so is this. So this is the one that's not filling correctly. During a flame test, lithium salt produces characteristic red flame. Why? Because the electrons are giving off energy, coming back down. Wave mechanical model, what is the orbital? A region of most probable location of electrons. Finally, bright line. Yes. Okay, so I got to do this right. So if you see the mixture down here, we're going to travel up. Oh, geez. Okay, it looks like D, maybe. I wish I had a ruler. Okay. Okay, so E and D. D and E. A. Please be right. 70 is A. Okay, good. It's hard to tell. Let me erase this for a second so you can see it. So what you'll do is you'll travel up from the mixture and see what elements hit the same pattern. So notice that it can't be G because G doesn't have anything right there. So it can't be G. All right? If you have any questions, let me know. Thanks for watching.